Hi, welcome to lesson 3 for the chapter on quadrilaterals. We've talked about general shapes, we've talked about family trees, we've talked about parallelograms, and now we're going to talk about these special parallelograms. So if you recall from the family tree, that include rectangles, rhombuses, and squares. So in the lesson for the second day, we reviewed these 5 facts about parallelograms, where you have the opposite sides are parallel, opposite sides are congruent, opposite angles congruent, consecutive angles supplementary, and the diagonals bisect each other. I think I wrote it in different words. That's fantastic. You need to know both based on however you read it. But there's some other things, like, for example, what makes a rectangle a rectangle? Well, there's 2 features, or rectangles, that are in addition to these 5 that parallelograms. Just remember that because it's a parallelogram, these 5 facts also are true for rectangles, okay? So when I'm looking at this, you not only have that fact, but you also have these 2 other ones. So here's what makes a rectangle a rectangle. This is almost, you could say, the definition of a rectangle is that all of the angles are 90 degrees. So it's equal angular. So that's what makes a rectangle a rectangle. And then there's a side benefit, and we use this quite a bit in construction. If we want to make sure something is square, so let's say we're framing a wall and we've got some studs and you nail everything in, there's no reason why, just because there's nails in it, that it couldn't just be sort of like leaning to a side. So the reason we need to measure the diagonals is if you measure those diagonals, and if this is exactly the same length as this diagonal, then we know it's square, or in this case, rectangular. So that's why we do it when we say it's square in construction. That's really what we mean, that there's all 90-degree angles. So this is an added perk. Diagonals are equal length for rectangles. So looking at rhombus, again, remember, all 5 of these rules are also true for rhombus. They're not separated. They're actually just part of it. So a rhombus has those 5 facts and 3 more. It's got all sides equal, which is the definition. Let me write that in black. That's the definition of a rhombus, is that all sides are equal. It's equilateral. Then it's got some side benefits. Again, these side benefits are things you probably have not seen before because these are diagonal related. For example, the diagonals of a rhombus are perpendicular. I should probably take advantage of this right here. If I draw these diagonals, look at them. They're 90 degrees to each other. Not only that, but when you draw those diagonals, it actually cuts the corners of the rhombus in half. So those angles are equal, those angles are equal, those angles are equal, those angles are equal. So it actually does a lot. So let's go back over to this rectangle over here. These are all right angles, but this equals this. So a fancy way of writing that is you don't just mark that they're bisected, you actually say that all 4 of those pieces are equal to each other. So then we've got all of these having the 5 facts of parallelograms, but the big thing is rhombus and rectangle are different. The rules for rectangle do not work for rhombus and vice versa. If that were to happen, if you did have a rectangle with 90-degree angles, and it also had all equal sides, well, in that case, you would have a square. So really simply put, guys, a square has all 10 facts. A square is perfect. It's got opposite sides parallel, opposite sides equal, opposite angles equal, consecutive angles supplementary, diagonals bisect each other, angles 90 degrees, diagonals are equal length, all the sides are the same length, the diagonals are perpendicular, and the diagonals bisect each other. So, diagonals bisect the angles, I should say. So a square does it all. It is the miracle baby, if you will. It is going to have all of this, all of this. Let me draw some diagonals here. It's got 90-degree angles here. It's got some this going on. All that's going on. It does everything. It is fantastic. So what we're going to do is we're going to practice these 10 facts. You need to know which shape is it based on, and you also have to remember, is a square a type of rectangle, for example? So a square would have those rules. So looking at these problems, given this information, what do we have that we can talk about. So for example, for number 1, you have opposite sides equal. So it's a parallelogram because opposite sides are equal. And it's got a 90-degree angle, which is a rectangle rule. Okay? And the reason why I can say that is because it's a parallelogram. That means opposite angles are equal and consecutive angles are supplementary. So really, even though they only gave you one right angle, it's got all 4. So the best answer for this is that it's a rectangle. Looking at number 2, we got all 4 sides are equal. Do I know anything about the angles? No. So you can say it's a rhombus, but you cannot say it's a square. Looking at number 3, you've got one opposite side that is equal. You've got these angles like this. Oh, look, those are alternate interior angles. Alternate interior angles means that these are parallel lines. So if you've got one side that is parallel and equal, that's a parallelogram. Here we've got one diagonal is bisected, but we don't know anything about this other one. So because we don't have enough information, you have to say it's a quadrilateral, because they don't give us enough to say more. Next row, we've got diagonals are bisected. That's a parallelogram rule. Number 6, look how the diagonals are bisected. See how all 4 of them are exactly the same side? Well, that's a rectangle. Okay, that's a rectangle rule. But this is a rhombus rule. So what's a rectangle and a rhombus? Square. Here you got diagonals, bisected, but not just bisected, they're all equal. That is a rectangle. We just did that. Because there's no other facts, that's all you can say it is. 8, the opposite sides are equal, but they're not equal to each other, so that's a parallelogram. 9, you got alternate interior angles again, so this is parallel, and this is parallel. So all you have is opposite sides parallel. So that's a parallelogram. 10, you've got diagonals bisected. That's a parallelogram rule. You got a right angle. That's a rectangle rule. So this is a rectangle. 11, we got one pair of parallel sides. We got 2 random sides equal. This is garbage, is really what this is. So this is quadrilateral. There's nothing that has that we talked about. Okay, we've got opposite sides, alternate interior angles. But look at the angles themselves. So we know it's a parallelogram, but this fact that these 2 angles are actually bisected, that's a rhombus rule. So it's a rhombus. It's not just a parallelogram. You have to say it's a parallelogram, but it's a special parallelogram. Number 13. Oh, there is no more. Oh, that's too bad. I could have done that all day. So those are definitely possible questions. Notice how I had to know which shape had the rule. I couldn't just know the rule. I had to know if it was a parallelogram rule or a rhombus rule or a rectangle rule. You have to know those because you have to be able to sort of identify the best case scenario. Another kind of question I could ask you is just true or false. For example, all squares are rectangles. Yeah, that's true. All squares are rectangles. If a quadrilateral has equal diagonals, then it must be a square. No, that's actually a rectangle rule. It doesn't have to be a square. A rhombus has 4 equal angles. No, it has 4 equal sides. If a quadrilateral has 4 equal sides, then it must be a square. No, it could be a rhombus. So again, we have to know the rules and know what shape is it really meant for. It could include more specific shapes, but it cannot be used to overly narrow things down. Lastly, I could give you problems like this, where I give you and I tell you in the directions it's a rhombus, and I say do some problems. I don't say how to do these problems. You have to actually understand, for example, that these 2 sides are equal to each other because it's a rhombus. You also have to understand that this angle right here is 90 degrees. And because of that, I don't need this right now. So instead, I'm going to have 2 problems. I'm going to have 16b minus 9 equals 3b plus 4. So that's 13b minus 9 equals 4. I subtracted 3b. I'm going to add 9. I'm going to get 13 and divide by 13. I get 1. b is 1. This one, because diagonals are perpendicular for rhombus, I'm going to say 14a plus 20 equals 90. So 14a equals 70, and a equals whatever 70 divided by 14 is. I think we can do that. I believe it is 5, and that is the answer. So let's go back to the original problem. What part of the rhombus will you use to solve? Well, all sides are equal. That was one property. And the diagonals were perpendicular. That's the other property I used. So TV, that side, is the same as all the other sides because it's a rhombus. So even though they didn't give us any information about TV, you could use 3 times 1 plus 4. 7, because every side is the same length. VZT, that's our 90-degree angle. You didn't need to find that information. And VTZ, that's that missing angle over here. So VTZ is this one, question mark. That's supposed to be equal to 5a minus 5. So it should be whatever 5 times 5 minus 5 is, which is 20. A lot of knowledge has to go into this problem. A lot's going on here. So let's look at this one. We've got AD equals 3x. I got BC equals 2y plus 1. I got AC. This diagonal is 4x minus 2. I've got DB, this other diagonal. Let me change colors here. This diagonal here is y plus 6. We've got some marks that say things are equal, so let's go ahead and write some equations down. 3x equals 2y plus 1. 4x minus 2 equals y plus 6. That's all we really know? That's so sad. So that means we have to do a system problem. Now, this one's sort of ugly in the sense that like there is no x equals or y equals. We don't have x's and y's on both sides. So no matter what, we're going to have to rearrange this. So I'm going to take this equation, I'm going to move it over to the left a little bit, and I'm going to rewrite it so it looks prettier. So I like elimination, so I'm going to make this 3x minus 2y equals 1. I move the 2y to the other side. I'm going to make this 4x minus y equals 8. I'm rearrange the 2 and I move the y. Now I'm going to make, the y is the same but opposite sign. So to do this, I'm going to multiply the bottom times negative 2. If I do that, let me rewrite the top problem here. I will end up with negative 8x plus 2y equals negative 16. Notice those are now equal to each other but opposite. So when I add these equations together, I get negative 5x equals negative 15, or x equals 3. I'm able to solve that really simply. For the y coordinate, or the y variable, I'm going to plug in what I have into one of these two equations, and I'm going to solve it. So I got 2y, 4 is y. So x is 3, y is 4. So let's write down what this is. If this is 4, and y is 4, and x is 3, this is 9. Whoops. The other one better be 9. So let's see. You know what? I made a huge assumption. I did all of this work, and I don't even know if I needed to do that. This has got to be 9 as well. I just realized I made a huge assumption. I didn't know those were equal to each other. I made a guess that these are going to be equal. I assumed that the diagonals were equal because I assumed it was a rectangle. Okay, if I had not done that, I would not have been able to do the problem. Wow, I should have gone a little bit slower. Last problem, here we go. So we've got these two this picture, it looks like it's a rectangle. ACD, we're talking about this angle right here. ACD is 15y plus 10. CAB is this angle up here, is 18y minus 2. You need to know that the opposite sides are parallel because those are alternate interior angles. So 18y minus 2 equals 15y plus 10. Ooh, gross answer. Y equals 8/3. Okay, this has got to be a rectangle as well in order to do the problem. So that's the idea, guys. We have a bunch of examples here, a lot of algebra, but it's not just algebra. We have to know the facts of rectangles, rhombuses, squares, and parallelograms in order to do these problems. So you do need to be able to identify shapes, be able to answer true-false questions, and possibly algebra.